Hello everyone, welcome to this session. From this session, we will talk about engineering case studies. So we will formulate different kinds of engineering problems to optimization problems so as to let you to solve them using AI techniques in the coming weeks, right? So let's start from the microwave engineering. Antenna is one of the most important thing in microwave engineering. So what is antenna? Antenna is a component that is used to transmit or receive electromagnetic waves. They are everywhere. So for example, you may often see these kinds of antenna, right? And you often see the antennas in your mobile, right? So these are all antennas. So the easiest or simplest antenna we can focus on in this session, we call it the dipole antenna. The dipole antenna is one of the most widely used one in radio communication. So let's see a simple case. So in this dipole antenna, we change the length L and the radius R, right? So each antenna with a different L and R, we have a different performance. So as you can see that in this figure, I fix the R value and I change the L value from 60 to 90. And we can see the response is different for each of them, right? So now we want to find the optimal L and R to meet the design requirements. So what are the design requirements? So we can see it here, right? So we want the magnitude of the S11 parameter, the max of it, to be less than 10 dB within the frequency range of the 1.8 to 2.2 gigahertz. So we can see S11, this is a performance matrix, it's a response. So this shows the magnitude of it. But this max doesn't mean that we are doing a maximization problem, but is a maximum value, a single value, right, of the S11 magnitude in the 1.8 to 2.2 gigahertz. So we want to minimize this value, right? So then there are search ranges. So the L is between 60 to 90 millimeters and R is between 0.001 to 0.5 millimeters. Okay, so knowing these requirements, we can set up the optimization problem. First, we know that what are the design variables. So we can know it's here, right? L and R, each one with a search range. Then we have a design requirement, right? We want the maximum S11 within the frequency range to be smaller than or equal to minus 10 dB. So we have two ways. Either we set this as a constraint, or we set this as an objective. So here we can choose it as an objective. It means we want to minimize this value. Maybe we can't make minus 10, right? But we want to minimize this, set it as an objective. So now the problem is formulated. We have the objective function, and we have the design variables, and each one have a search range. The optimization problem is formed. For the next step, we can solve this problem. Okay, that's all for this session. Thank you very much.